Good morning, everyone. Thank you for joining Nota 3D. Today we're going to be talking about Geomagic Control X. My name is Jeff Moody. I'm going to be your presenter today. I'm the Business Development Manager for software for Nota 3D. A little bit about myself. I am a former employee of 3D Systems that worked heavily with a bunch of different softwares, one of them including Geomagic Control X. We also offer Geomagic Design X, Freeform Plus, DICOM to Print, Geomagic Wrap, and 3D Sprint. Today in particular, we're going to be focusing on Geomagic Control X and its capabilities. I'm going to give a few reasons why to purchase Geomagic Control X over our competitors, and then we'll get into a technical demonstration. To start off, Geomagic Control X is designed for everyone. Our motto is ensure quality everywhere, and that means ensuring quality for everyone. We wanted to make it as easy to use as possible for everybody. So that's not just the quality engineer, that's the technician, the person scanning the parts, the people that need to see the reports, everybody. Our software is incredibly easy to use. The layout of the software is very user-friendly, it's easy to understand, and it takes about a day's worth of training to become completely competent in its capabilities. We're going to be talking about the 3 steps that we need to complete a inspection routine, and we'll talk about the UI as well and how it all works and how it fits together. A lot of the times people are really concerned that making an inspection routine is extremely complicated. In our software, it's very, very simple. Basically, you just pick and choose the components you need and then add those to in the inspection routine. To do this, you start off with the first step, and the first step is an alignment. So you take a look at two pieces, your reference data and your measured data, and you need to get them over the top of each other. Now, depending on what you need to do, or depending on how you want to compare these two, we have a bunch of different ways to align. We do need to do that in 2 different steps. First, using an initial alignment or a transform alignment, and then using one of the other various alignments that we have. Because you can scan directly into Control X, we have some different automated tools called adaptive alignments and homing alignments. But the rest are manual tools that allow you to pick and choose independent features on the measured data to align to. The second step is to do an analysis. There are several different ways to do an analysis in our software. First off, you can do an overall comparison with a 3D compare. You can also do that in a cross-section using a 2D comparison. You can interrogate the most deviating points using comparison points. And then we have various other tools that allow you to compare the two in different ways. We also have an entire set of GD&T, which allows you to put down all the GD&T constraints that you could possibly want. And then we also have easy-to-use dimensioning. The third step is to put out a report. So all of this easy-to-use stuff is really great, and it's completely useless unless you can put out a really, really nice report. To do this, we have a report manager that allows you to modify and edit things similar to the Word program. And then we also have the ability to do batch processing and trend reporting. So I'm going to go ahead and step into the technical demonstration now. So first thing I'm going to do is I'm going to talk about the software and the layout of the software, kind of the UI of the stuff. And then I'm going to go ahead and get into creating an inspection routine. So on the left-hand side is the actual inspection routine itself. We call it result data. You can have multiple result data in one project file, which is really nice. If you have 3 or 4 different parts, you can duplicate this result data and then just swap out the measured data as you see fit. These things here you can consider as buckets. They allow you to fill different things, and I'll show you how that works here in just a second. Up on the top is our tool set, and it's laid out in a ribbon layout. If I select live capture, we have a bunch of different tools. If I select CAD, we have a bunch of different tools as well, just depending on what you need to work on and what you need to do. Down below that is the upper side toolbar that allows you to change your views, select different types of things using these features over here. On the right-hand side, we have a Properties tab that doesn't display until you actually have something selected. So if I select my measure data, then I go over to the Properties, it gives us a lot of useful information. So we can tell how many points or polyvertices are in this model. Right now we have 249,000. We can also calculate center mass and different things. Right now I'm working with a point cloud. If I had a mesh file, it would give us all the information about the mesh as well. Down below, we have a filters toolbar. So this allows us to filter our view, and it allows us to filter our selections as well. And then we have a basic gut check measurement devices over here. So now to start creating an inspection routine. So how do we do this? Well, first I import the data. In this case, I'm using a CAD file, and I'm comparing it to a scanned point cloud. I took a part, scanned it in the real world using several different devices, and then brought that into my software. And you can see them here. Now I need to do the first step, which is creating an alignment. In this case, I just want to use a best fit alignment, or I just want to use a quick alignment just to see what happens. So I'm going to start with an initial alignment. Then I'm going to tell it to do it quickly. Once this is done, it's going to populate over here on the left-hand side. So under my alignments bucket here, I now have an initial alignment. I'm also going to go ahead and do a best fit alignment since I really want to hone this in and make sure it's as tight as possible to all of these features on my CAD model. I'll select best fit. And the important thing about my best fit is I want to tell the software to take a look at more of the data than less. So to do that, I'm going to tell it to look at 90% of the point cloud, and I want it to try to get a best fit alignment maybe 25 times. So go ahead and say okay, and let it run. If I wanted to, I could select independent faces. This is not a datum scheme, but I could just choose one or two individual faces. We do have an independent datum alignment. If we have datums on our technical drawing, we can use that to create a datum scheme. So that's the first step. And right away, we can already see that we have an issue with our manufacturing. Our CAD file, the gray file, is perfect, but here the green point cloud is clearly bent out of alignment. So we need to do an analysis on this. And to start, I'm going to start off with a 3D compare. So this is the overall color. This is the overall color map that people really like to see and really gets the point across to the managers or to whoever needs to see the information. So I'll select 3D compare. I'll go to the next stage. And here we have a bunch of different information. So to start, my color bar is looking in the positive direction 1 millimeter and in the negative direction 1 millimeter. I have a tolerance zone of 0.1 millimeters. And here we can see that this area here is way out. It's out farther than 1 millimeter, probably. And this is a pretty good indication. If it's blue, it's inside the CAD model. If it's red, it's outside the CAD model. So as we saw before, the mesh is very off. Or I'm sorry, the point cloud is very off. And I might want to change this up a little bit and make it a little bit more dynamic. To do that, I can turn on show contour lines. This kind of gives it a topological view, so it's really easy to define where the deviations are changing. I can also create a whisker plot. So if I zoom in here, I have lines that are basically drawn from the CAD part to the mesh to where it's comparing, and you can see how much it's deviating. And I can increase or decrease this whiskers. So if I have too many whiskers here, I can take that down a bit, just reduce the amount of whiskers that I have available. And then I can also colorize the point cloud itself instead of the CAD model. And since I don't have a whole lot of data in this CAD model, it's kind of granular and doesn't look as good as I'd like it. So I'm going to go ahead and keep it on color map. In addition to this, I can also show the highest and lowest deviating point. So I do have the ability to find the highest out point and the lowest out point. In this case, it's the farthest out and the farthest in point. Those happen to be up here. If I don't have enough information on these tags, I can easily change them to one of the presets that I've already defined for myself, and I'll go ahead and select detailed. And I can change these presets up to make them more manageable, so to make it easier to kind of define that. I'm going to go ahead and turn this off in this case because I like to have this picture just kind of by itself. So I'm going to go ahead and hit OK here. And then maybe there's a specific area that I want to take a look at and define a little bit better. Maybe I want to do a cross section of this. So I'm going to go up to the 2D compare. And then I'm going to choose an axis here. I don't need to create any planes or anything like that. I can just use the X, Y, or Z of the global coordinates. And since this part was built correctly, it's easy to move, or it's easy to identify. If this is not exactly correct, I can always offset my plane. So I can come over here and say, I need to be right here somewhere. Then I can go to the next stage. When I go to the next stage, it puts me in a 2D view, and I can definitely see what's going on here. So absolutely, there's some deviation here. So I might put down a tag here, put down another tag here. I might change these to, let's just say detailed. This gives me a little bit more information. We can see in the X and Y my reference data, my measured data, and the deviation between the two. So it looks like in this particular area, this is deviating by 1.6 millimeters, which is not good. This is obviously failing my quality check. Take a look at an area that is passing my quality check, and I'll put that right about here. So here we can see my tags are also green, so it's a big indicator to the higher ups or to whoever needs to see my report that these areas in particular are failing and this area is good to go. Also in the right hand side, the color bar is also showing this kind of jaggedy line, this kind of mountainy line. This is a histogram of the total points in the model. So, this is a histogram of the total points in this 2D cross section. So here we can see we have not a whole lot of information in my tolerance zone. We have quite a bit in the positive and quite a bit in the negative direction as well. So, okay, I'm happy with this. I'll go ahead and say okay. I'm going to go ahead and turn that off. Then I might put some comparison points down in some areas of interest to me, or if I have some points, critical points that I need to check, I might put those down. So I'm going to come up and select comparison points. And I'll just put down a couple points. So maybe here I'll put a point, here. And we can do this in a bunch of different fashions. I don't have to do these all manually. I can choose along a curve or along a line, linear pattern, different things like that. So if I wanted to check this top of this face here, all I need to do is set a seed point, and then I can give it a couple directions to go in. So if I put in 4 here at 3 millimeters, and I choose this line or this edge, then I choose this direction as well using this edge. And then I give it 4. I can kind of get like a pattern going of what I'm looking for. And I can update this. There we go. Number of instances, and maybe we'll just drop this down to 2 instead. And increase this by 5. And then this will give me all the kind of deviations on each one of those points. So I'm going to go ahead and send these tags to the outer bounds of the imaging area. Kind of makes it easy to use and really easy to understand. Instead of having to manually move around each one of these individually, I can just choose this tab up here that says automatic, and it will move it to the most outer bounds of my viewing window here. Okay. So now what if I don't really want to do any kind of color overlays or anything like that? What else can I do? Well, I can hide my comparison points, and I can go up to the Dimensions tab. In the Dimensions tab, we have the ability to dimension things in 2 dimensions and also in 3 dimensions. But the really nice feature about our software is I can use the faces themselves as dimensioning tools. So similar to all of your CAD packages, when you select a line in your sketches and you use some smart dimension, we also have that feature in here. So I'll select the smart dimension, and this is kind of an amalgamation of all 4 of these tools here. And all I need to do really is select faces. So for example, if I want to get a linear dimension from this face and this face, I click both faces and then just drop the dimension. Again, this is really, really user-friendly. It should be easy to use, and it should give you kind of the reference geometry already, whereas in our competitors, you have to apply reference geometry first and then take a dimension from that reference geometry. So since I'm using the Smart Dimension, all I need to do is select different faces, and it knows what dimension I want to put down. So instead of doing a linear dimension in this cylinder, it gave me a radial dimension. And maybe last but not least, I'll go ahead and put in a slot dimension as well. And maybe I'll tell this slot that I want to look at, instead of the center points, I want to look at the max bounds, so just the outer portions of that slot. So I'll go ahead and say OK there. And we can also put down datums and GD&T. So this is really nice when your technical drawing has these kinds of features. We have the ability to put all of these down in all sorts of different flavors. So I'll go ahead and put it down 3 datums really quick. Let's see, one more. I'll just say that. If I'm taking a picture and I don't want this in this area, I can rotate this around so it's in a better view. I'll go ahead and just say OK there, and I'll drag this out of there. There we go. We also have the ability to set groups over here on the right-hand side. So I have my my dimensioning and my datums in the same group, and I don't particularly like that. So I can go ahead and create a new group by adding a group, and then I can click and move these to my second group. This is important for when we create the report. I want to have a nice report, so maybe I want to separate the datums from the dimensions, and then I also maybe want to put a GD&T in a separate group as well. So again, I'm going to right-click and select Add Group, and then I'll go ahead and put in a couple of datums, or a couple of GD&T as well. So I'll put flatness on this one, on datum A. Say OK, and maybe I'll put circularity on, let's just say datum B. And let's do perpendicularity on just this base that's perpendicular to datum C. Say OK, as just an example. So now I have my group number 3 has all of my GD&T callouts. I can go ahead and move on to the third and final step in my Control X inspection routine. Again, you can see that they're all of this stuff that I put in is populating over here on the left-hand side. So in this case, I'm pretty happy with it. And I'll go ahead and select Generate Report. This brings up the report template builder. I have a bunch of different ways to create a report. If I want to do a letter landscape, I can do that. I have for a portrait, and then I have the letter, portrait, and landscape, but I can also create my own if I want to. I'm going to go ahead and kick some data out because my first alignment is not useful. So my initial alignment doesn't give me a whole lot of information. So I'll just remove that so I don't have to present that to whoever needs to see this data. So again, the whole purpose of this software is to make this report as efficient and easy to understand as possible. So I'm going to go ahead and put in a 3D PDF as well. Down here, I can also add in the title and subject, author, part name, and a whole bunch of different information. I'll go ahead and select Generate. And this brings me into the report template editor. So this is where you can add in and take out and remove things as much as you want. We can also save our reports in different file formats. So we can save it as a PDF, a PowerPoint, and an Excel. And here we can go ahead and add in a bunch of different information. So if I want to put in my name here as the inspector, I can come up and edit that and put in my name. And there we go. Now this 3D PDF will not display unless you save it as a PDF, and then once you save it as a PDF, it will then display after you've trusted the document. Here is our reference data. Here is our measured data. Here is a best fit alignment with a histogram of the alignment, and it has the minimum and maximum deviation, the average RMS value, and standard deviation as well. Here is my 3D compare, and this to me is really the crucial image here. It kind of gives you the overview of exactly what's going on with your part, and it also gives you the min, max, and average and standard deviation of this comparison. Here is our 2D compare, and this is where it gets a little bit interesting. So here is where the 2D compare was taken. And we can see here that I have like a deviation tag that's kind of going through the color bar. So this is maybe not the best picture, maybe not, it's not, representing what we want to see effectively. So I can come back into the project file, go back to the 2D compare, tell the software to take me to when that picture was taken, and I can just modify that. Bring that in here and here. And then I can say, I can tell the software to reassign that viewpoint or retake the picture. Then I can go back into the inspection report. And here I get a couple of arrows, and this is telling me that something has changed and I need to rebuild it. One of the nice features about our software is it will take a look at just this picture and rebuild this picture instead of having to delete the entire report and start again. So now I've changed the location of these tags, and it should be easier for whoever needs to see this, be able to see it more effectively, I guess. So down here is our comparison points in a tabular view. That is these points just kind of displayed in a tabular view, and it gives you all of the information. I can change this table up to add in or take out other information if I want to, but we'll just continue on. Finally, here's our comparison points, with our comparison points kind of out on the outer edge of our viewing window. So it zooms into just this location and tries to identify this as best as possible. I don't have the color view, or I don't have the color overlay displayed, but again, I can go back into the project itself, go to my comparison points, tell the software to take me to when that picture was taken, and instead of having this gray CAD model out here, I can turn on my 3D compare, which will really help people understand what's going on better. And then I'll say reassign viewpoint. At that point, I can then again go back into the report and select rebuild. There we go. And this to me is a much more manageable picture. And again, we have all of the comparison points down here in a tabular view, which makes it very easy to understand. So in addition to this, I'm going to go ahead and go back to the slide real quick. We now have a new price structure for Geomagic Control X, whereas traditionally it was around $18,000, but now we are offering it at $500 a month. So we will be working with our customers to finance this software in kind of a SaaS structure to make it more manageable to get into Control X and start doing inspections. And with that, thank you very much. And I'll go ahead and take a look at our questions. Let's see. So the first question is, what type of scanner do you sell? The type of scanner that we sell, actually, we don't really sell any scanners. We integrate with all types of scanners, though. We integrate with Artec, Creaform, Hexagon, Faro, Shining 3D, just a myriad of different scanners. And if we don't directly integrate, if you can't scan directly into our software, you can always export an STL or a file that we can read, and then you can work with your scanner that way. We work with a ton of different file formats, and we don't charge extra for that. So our competitors charge you extra to work with PLYs or OBJs or E57 files. We don't do that. Our second question is, what file formats can you import? Good question. So I'm going to go ahead and go back to the software really quick, and I'll choose my importer. Let's see, import. And if I drop this down, we work with all of these different file formats. So not only do we work with very, very small scanners, but we work with very large scanners as well. So we can work with LiDAR data. We can work with structured light scanners. We can work with laser line scanners. We can work with a bunch of different stuff. We can also work with CMMs. So if you have a CMM that you already have, you can import the CMM data and compare it against your CAD model here. Our last question is, can I scroll over anywhere on the part on the color map to get the deviation and add that to the report? So the best way to do that, I would say, is to use the comparison points. Like here we're seeing about -1 millimeter, but that's probably not going to be as useful as you want to get that information into the report. So I would use a comparison point and put a point there. And I'm going to go ahead and wait for just a second just to see if there's any more questions. And I think we're just about on time here. Oh, okay. So we got another question. What are the main advantages over CMMs? So CMMs, even though they are highly, highly accurate, they are incredibly slow, and they are trying to pick up speed, but they will never be as fast as scanning a part, putting them over the top of the CAD part, and getting that comparison. In addition to that, when you use the CMM, you are only getting as many points as you program in, and a good programmer might program in up to 1,000 points. In here, if I highlight my scan and go over to my properties, we have 249,000 points that we're comparing against a CAD model. So this gives you a much broader overview of what's going on with your part, as opposed to just several points that you have to then infer the rest of your model. Good question. And with that, again, thank you very much, and have a good day.